review video. This is a review video number 6. And for this one, I want to look at the quadrilateral problem. These are 90, 91, and 92. These are nice because they sort of tie a little bit of geometry and algebra together. So if we look at the sketch, there's this quadrilateral. It appears to be a parallelogram. This right-hand side appears to be parallel to that, although we don't know it's parallel yet. I think we'll end up with that. And then we have a side up here, and the vertices are labeled A, B, C, and D. And then the measures of the angles are called X and 2X and 3X and 4X. And the first thing we have to do, problem number 90, is to write an equation. So problem 90, we know the angles of a quadrilateral, all 4 angles, must sum to 360 degrees. And you can sort of remember how that works. I mean, if we were to split this down the middle, you see there's 2 triangles here. There's a triangle, that's 180 degrees. There's another triangle over here, that's 180. 2 triangles have to add up to 360. So that sort of makes sense. Let's go ahead and write that equation. We have x plus 2x plus 3x plus 4x has to be 360 degrees. We add all these up. We have 10 x's is 360, so x is 36 degrees. Okay, now that was problem 90. Problem 91 says what's the largest angle? So let's go in and let's just start labeling this one. X is 36 because we said that down here. And then 2x would be double that. That's 72 up top here. 3x would be another 36, so we're at 108. And 4x would be 144. That's gross, 144. Okay, so there's our 4 angles. And again, you could just double check if you add those 4 numbers up. You should certainly get 360 degrees. Okay, so the question was, what's the measure of the largest angle? So 91, the largest angle in ABCD is 144 degrees. This one right here. Okay. And the last thing is, can you make any other conclusions? Well, I sort of said at the beginning, these 2 looked parallel, this side and this side. And now we actually know they are. Note that if you have 2 lines and cut by a transversal, and they form supplementary angles on the same side of the transversal, 72 and 108 are supplementary, then these lines do in fact have to be parallel. And you don't have to use those pair. You could come down to the bottom end. We have these 2 lines, again, cut by a transversal, forming supplementary angles on the same side of the transversal. So these lines are in fact parallel. Okay, so what kind of figure? Well, I would say 92 is a trapezoid. So for 92, A, B, C, D is a trapezoid because it has one pair of parallel sides. Okay, that's not too bad. And by the way, here's a sort of a related question. Is this an isosceles trapezoid? Isosceles trapezoid? And I hope you could answer that pretty easily. No. If it were isosceles trapezoids, base angles are supposed to be equal. But if you look at the angle up here at B and the angle at A, they are not equal. Base angles are not equal, so this is not an isosceles trapezoid. Okay, let me stop this video here, and we'll pick back up doing some more polygons in video number 7. Let's see. We'll probably go back and look at problems 48, 49, 50, and 51.